My name's Jonathan Giles. Beside me I've got two of my colleagues on DataFX. For those that don't know me, I do UI controls in the JavaFX team. What my main focus is on is the controls like list view, table view, tree view. And about 2011, Johan and I were chatting and we realized that these controls needed a way to get data into them. You know, it's not just good enough being able to show data, we needed a way to populate them. So Johan and I chatted and we realized these controls are all based around the same kind of concept of an observable list. And so we set about building what we now call DataFX, and it was 2011 at this Java 1 that we announced the first release. Since then we've done a few more releases, but as I said, I'm a UI controls guy. I live in an imaginary world where I don't build actual applications. I just sit in my office and build lists and trees and tables, and I never actually put them into real-world use. Where these guys come in is that they build real-world applications, and they also know enterprise stuff. And as a pixel pusher, enterprise stuff just puts me to sleep. So we're very lucky to have these two guys who have pretty much taken over the project. And I pretty much just stand up and do the introduction, then I sit down for the rest of the session and I'll leave it to them. So to introduce who's here, well, I've said who I am. I'm Jonathan Giles. I'm an Oracle employee. I do UI controls in the JavaFX team. On the further side from me is Johan Vos. He's a Duke's Choice Award winner, so everyone should give him a pat on the back when they see him. He's been working not just on this project, but also on JavaFX on Android, so it's a very cool project, and it's really cool just to see him bring out his phone with a map application running on Android, all written in JavaFX. Beside me is Hendrik Ebbers. He works for Canoe, and he's got his website GUI Garage where he blogs about all the stuff that he's doing with various projects, AquaFX and various other things I'm sure he's going to talk about in other sessions. He's got, how many sessions do you have? About six? Or six? Yeah, six sessions. So, he's going to be talking about all his projects this week. So, leaving now, I'll hand it over to Johan, who's going to talk for the first half.
You're really tall. Okay, thank you, Jonathan, and thanks for initiating this DataFX project. And I think it was very good that someone from inside the Oracle JavaFX team realized that we have these nice controls with observable lists and observable values. Now we also need something to get external data being visualized in these controls. So that's one of the parts of the of DataFX, which is what we call the data sources part. WebSockets is now part of data sources. I will come back to that later. And these things are about how you can get external enterprise data in your JavaFX project. The second part of this presentation, which Hendrik will guide you through, is about how you can use enterprise functionality inside your JavaFX application. So it's pretty complementary. We use two different approaches. In some projects, one may be more suited than others. It depends on your use case, your configuration. Are you using JavaFX on embedded, on mobile, or on desktop? So that really depends what parts of the DataFX components that you can use. So the goal of the data sources component is that we want to facilitate the interaction between JavaFX applications and data that is at backend services. And thereby we want to respect the differences and the commonalities between those two often completely different worlds. So the world of embedded, of enterprise is still typically cloud-based service with lots of resources, and the client world is much, much smaller, often contains much, much smaller devices. So data sources, the whole project is open source, and you can get the source code at Bitbucket. We will provide a link on the website, of course. So I'm not going to go to the internals too much, but very briefly, in DataFX, the data source part contains three pieces. First of all, we have some clauses that allow you to read data from an enterprise component. Then another piece that converts this data into Java or JavaFX beans. And then the last part will provide this data to the JavaFX controls. We use standard protocols, for example REST, to communicate with enterprise layers. And that also makes it possible that you can use the same backend on different clients. It can be a web client, can be a JavaFX client, can be a JavaFX client on iOS or on Android. So DataFX 8, our latest version, runs on JavaFX on Android as well. So the protocols that we support with the data sources are REST, ServerSent Event, and WebSockets. And we support technologies like XML and JSON encoding. We also have support for JDBC drivers and for accessing the native file system. I think it's very important to stress that the DataFX is not just retrieving data from a backend. It's really tailored for JavaFX. So we try to leverage whatever we have in JavaFX. And one of the cool things of JavaFX is the notion of observable and observable list. So the data sources in DataFX will make sure that your JavaFX controls get populated, that the observable list backing a list view is populated with the correct data. So you don't have to retrieve the data and then write some callback handlers that will populate the list items and so on. This wiring is done for you. Also, you have to be careful in JavaFX that whatever you do that might change the UI happens at the JavaFX application thread. And that's also something that DataFX does for you. So, as I said, three main pieces in DataFX. So the first part is where we read the data. And what I will show in a few minutes is that we can read the data amongst other protocols from REST-based web services, from SSE endpoints, ServerSent Event, and also from WebSockets. Then we convert this data into JavaFX, into Java objects that can be JavaFX beans. DataFX provides an XML converter and a JSON converter out of the box. So we have a JSON processing piece as well. So if your data is in JSON or XML, it can be automatically converted to Java objects. And then the last part will provide the data as observable instances or as items in an observable list. So again, why is the integration with JavaFX key in DataFX? Because if you use the data sources, then your data can be kept up to date in your controls. And for example, for ServerSent Events, this is very important. Maybe I should have asked first, how many of you are familiar with ServerSent Event? Okay, and WebSockets? Okay, so WebSocket seems to be more popular today than ServerSent Events. But I think SSE is increasingly being adopted, especially in web technologies as well. But the important thing here is that data sources will make sure that your controls are kept up to date when new data comes in. The JavaFX controls, like for example label and list view, they often use observables and observable lists. For example, if you want to set the text on a label, you populate the text property of a label. And DataFX will do the remaining part. It will make sure that the text comes from a backend, and if the text is updated, that the label will be updated as well. So I will show three examples of this. The three examples are based on Project Avatar. Project Avatar was announced last year at Java 1, and it's a project from Oracle with JavaScript on the backend and JavaScript on the client. And what they showed there was that you can have a JavaScript backend that actually runs in a Glassfish application server, and you can have a JavaScript client. It's something like AngularJS, for example, and both communicate using standard protocols. So what we did was, okay, we will take the server for whatever reason that you want to have JavaScript on the server, but in case you really want JavaScript on the server, fine. And the JavaScript on the client, nah, that's too much. We will take a JavaFX client instead of the JavaScript. But we will use the exact same protocols, and we will also connect to the server and show that the functionality is exactly the same. Avatar demonstrates or uses REST, ServerSent Events, and WebSockets, and they use JSON as the encoding format for doing the transportation. And with Avatar FX, which is a project that we also have in our Bitbucket repository, we demonstrate the Avatar functionality in a JavaFX client. So, first of all, the REST part. The REST part of the data sources is similar to the functionality provided by JAX-RS 2.0 client API. But it's more simple because the JAX-RS client API is part of the Java EE standard. And one of the reasons is that most of the use cases for JAX-RS client are servers that are initiating connections to other servers. And then you have, of course, much more resources, which you don't always have on laptops or mobile or embedded devices. So that's why we're not using the full JAX-RS client API, but we have something simple. If you want to develop using it, you can use builders, or you can use the getter-setter approach. We also provide OAuth support. So if you need to communicate with a backend that requires OAuth authentication, that can be done with DataFX. You provide key, secret, and hashing is calculated for you. And of course, the protocols get post, put, delete, or supported. And I will now show the example of how to use REST services in data sources on laptop 2, I think.
Yes.
So, is this... Now I'm... Okay. So, first of all, I have to start the client. This is today we use Gradle as the build and deploy system. So we have here the JavaFX application that we just start with Gradle run. And you see I created the layout. And it's very easy to know who created the layout. If it looks like this, it's either James Gosling or me who created it, with a fair chance that it's the latter one. So these are 4 examples, but look at the hover. That's nice, but that's actually built in JavaFX. So the first sample is what we call the web store. This is exactly the same as the Avatar example, but they have a web client for it. If we click on Get All, we get the number of key value pairs. I can add some item, key 2, value 2, and we put it, and you see it's now in the list. We can ask the value for key K, and then we see here the value is V, which is about right. So that's not very impressive, but you probably understand the use case. So this is read, write, update, delete things. So quickly going to the code of this, to the relevant code snippet. Is that readable, more or less? I hope so, because I have no idea on how to increase the font size on Mac. Yeah, like this?
For me, it's working.
Okay, yeah.
I don't know.
For me, it's not working. So, anyway, these examples are open source as well. They're on the Bitbucket repository, bitbucket.org/dataFX/avatarFX. So, how do we retrieve the items? We first create a converter. As I said, step 2 in the process is that your data is converted. It's step 2, but it always helps to create a converter first. We have a JSON converter because, as I said, Avatar is going to send the data in JSON format. So the JSON converter that we create is created here. So what we supply is that we expect a number of items, and the items are separated by the tag items, and they are of, each item is of class item.class, which is a very simple class with just a key and a value. So that's probably not the most complicated example. Then we create a REST source, and in this case we use the builder pattern, but you could have done it with getter setters only as well. We create a REST source builder. We tell it you will receive data, and you have to use this converter that we just created to convert the data into item instances. The host where the REST services is residing is some constant here. Then we supply the path, so the context root of the avatar application is demo REST, and then we have to call another part of the path which is data items. So this is actually what you typically do in a REST-based application. You specify the address, and then that's it. Then we have the REST source. In order to populate a list view with this data, then we create a list data provider. Again, we use the builder pattern here. And we tell the list data provider that you have to use this data reader, which is the REST source that we just created. So we told it, your data will be read by this reader. And I want you to put the result in all items. All items is an observable list containing instances of item. So the moment that DataFX is reading items, it will start populating this list. And then finally, we call the retrieve method on the list data provider. This will create a worker, and it will start doing the work. There are a number of ways that you can get the result, but what we did here is we didn't do anything. We just said put the result in the all items variable, and then what we have in the controller of our JavaFX fxml file, because of course I had to use fxml to create such a complicated user interface. You see that we have a list view all items, which is this very complex list view. And when we initialize the fxml view, we call the set items on the list view, and we populate it with the items property that we had in the web store app, which is the all items that we were populating. So that's all wiring that is needed. So the moment that new data arrives, the all items will be populated. So this is only demonstrating the get all items. I didn't go over the get item and the push item and the delete item, but that's pretty similar. So, but this demonstrates how to use REST in your JavaFX application, talking to a REST backend with the data sources. So maybe some music while I'm walking up there. Hi, here. Okay, here we are again with the second part of the demo, which is about SSE. SSE is ServerSent Events, and because I didn't want to take the risk telling something wrong about this protocol, I just copy-pasted from Wikipedia. ServerSent Events is a standard describing how servers can initiate data transmission towards clients once a client initiated a connection. So there are many use cases for this. A typical one is that a stock ticker. You want to be informed when the value of a stock changes. So as a client, you first send a request. I'm interested in the values. The server immediately sends the current value, but maybe it changes 5 seconds later or 10 minutes later. And the server will then send the updated value. And client and server, they use the SSE protocol to keep the connection alive or to re-establish the connection if it fails. So this is actually something between REST and WebSockets. So ServerSent Events are actually part of the HTML5 technologies. So yes, we embrace HTML5. I never realized that before. So it's something that's getting more and more popular in recent web applications, and we also support it now in JavaFX. So I will show. I already explained this one. So what we do in DataFX is that we create an observable object, and every time that new data comes in, the observable object changes. And that's pretty cool that JavaFX has this notion of observable, so that whenever the data from the server changes, your control will change as well. So, whoa. There are two examples here, but I will only show the clock, which is a very typical example, but useless, of SSE. You see that the avatar server is sending us updates every second, and you see that the time is changing here. That's not very sexy, but that's just data coming in every second, and the property here is being changed every second. So very briefly, the code for this, the clock up is initiating this connection because we have the retrieved data here. It's very similar to getting REST data, but this time we use an SSE, REST source builder, that retrieves that initiates the connection. Is similar to the REST source builder. We provide a converter, which is now using the time.class, class, a host, a path, and we build it. And then we have an object data provider in which we say the result of this should be in a property called timeholder. Timeholder is an object property of time. So every time the server sends a new instance of this time, we will change the properties in this time class. So in the user interface just displays the value of time. And DataFX will make sure that when the value is changed on the server, that these properties are changed as well. Hi, and welcome again to part 3 of the demo, which is about WebSockets. So that's the final part, and then I leave it to Hendrik. WebSockets are standardized in Java as part of JSR 356, which is actually the server-side standardization. But the client protocol is very useful on clients like JavaFX as well. We leverage it with DataFX. Again, it's very lightweight. It still works on mobile. So what DataFX will do is we will, using the same techniques, we will retrieve incoming messages and populate observable lists once new messages are being sent over the WebSocket session. So the obvious application for this is a chat application. So if you join me for the next demo, you will see what I mean. Thank you, Johan. We will now show the chat demo, as you just explained. So first of all, we have to log in, and if you don't mind, I'm going to use your name for logging in. So we now see that Johan logged in into the chat room, and I can talk to myself like I'm doing the whole time. Hi, Johan. So that's just yet another chat application. Very briefly, the code for this chat application. Chat app. Here it is. So where do we handle the connections? Once again, we start with a JSON converter because we will get JSON strings, and we convert that to instances of chat message, which can be a login message or a hi message or a private message and so on. We create a WebSocket reader, the equivalent of a REST source. We provided the address of the REST source, of the WebSocket backend, sorry. We set the converter to it. And then instead of a list data provider, we create a message provider, which is typically for WebSockets. And we tell it the result observable list is messages, which is an observable list of messages. And then we start it by doing mp.retrieve. Now, every time that DataFX reads an incoming message on the WebSocket, it will put this on the messages observable list, and then we can do whatever we want. So messages here is the observable list of chat messages. So we can write that to a list view or whatever you want to do. Once again, you don't have to worry about being on the JavaFX application thread or not. And you don't have to worry about missing callbacks because that's what DataFX is doing for you. So that concludes the part of how you connect your JavaFX application with external enterprise data. And now it's up to Hendrik.
Okay, first we add an ad. So before I will start talking about the flow, Johan and we've written some JavaFX books. So if you like JavaFX and want to know more about JavaFX, you should buy these 2 books. And if you buy them at Java 1, you will get a free teddy. So even if you don't like JavaFX, you will get a teddy. If you buy 2 at Java 1, you should do it. Okay. Oh yes, before I will start talking about the Flow API of DataFX, I will go one step back and talk about concurrency. The data sources have a lot of concurrency stuff inside to manage all the background threads that receive the data and all the stuff. And we extracted all the concurrency utilities that we created in an extra module. It's called DataFX Core. And all other DataFX modules, like the data reader or the flow, include this module. And if you develop a JavaFX application, there is a lot of useful stuff in this module that you can use in your JavaFX application too. And I will show you 3 different utilities. So, as I said, I want to talk about the concurrency API in DataFX. And you might know that JavaFX is a single-threaded toolkit, like any UI toolkit. So you only have one thread for the UI, and every operation that takes a long time, like calling a REST service or something like that, will freeze the application, so the UI, if you do it on the application thread. So you shouldn't do it. And what we've done, we've created some helpful classes. The first one is the DataFX Executor. It's an implementation of the default Java Executor interface, like a thread pool or something like that in Java, but it has some additional options and methods. So, as an executor, it will support runables and callables, but it supports services and tasks, so the JavaFX concurrency classes too. It will support for all the task title, message, progress, like in the new JavaFX tasks, but you can do it in runables and callables too. You can cancel tasks, and you can configure the thread pool on that the executor depends. And by doing so, you can do some cool stuff. I will show you a demo. Okay, so what I did here, let me see. Can you read it? I think so. Okay, what I did here is I created an observable executor and a list view. And the executor provides a property called current services. This defines all the services that are currently executed in the executor. And then I have a button, and when pressing the button, I will submit tasks or runables or callables to the observable executor. And when I start this example, here on the top there's a list, and here's a button. And when I press the button, I see what tasks are currently running in the executor, so in the thread pool. And I see the title of the task, I see the description, I see the progress, and if the task is cancelable, I just click and the task will be removed. So it's like this progress window in Eclipse, for example. You can do this very easily by using the observable executor. Okay. Another one is JavaFX only provides or didn't provide a run and wait method. It's only in the private API, and in DataFX we have implemented a run and wait method that works with a runable or with a callable and will return the result of the callable. Then we have stream support. Normally the streams in Java 8 won't fit to JavaFX because they are not running on the application thread. And with StreamFX, it's a DataFX class and it's a wrapper around a normal stream. You can do a lot of stuff that you can do with streams on the JavaFX application thread. Like you have a stream and do some stuff in background in parallel, and you can say StreamFX for each ordered, and the result that you have done in all your background thread will be handled in the JavaFX application thread. And the third tool that I want to show is a process chain. It's like, so people who did Swing may know the Swing worker, and the process chain is like the Swing worker for JavaFX. So you can handle background tasks and tasks in the application thread. And here's some code how this might look. So I created the process chain and say, okay, at first I want to block my UI. I need to do this in the platform thread, so in the JavaFX application thread. Then I want to load some data from the server, so I will do it in an executor, so in the background. And thanks to Lambdas, I can use a supplier here, and the supplier returns some value, so the data that is loaded from the server. And as a next step, I can add a consumer that will be handled in the platform thread, and by doing so, this consumer will get the data that is loaded in the background thread from the server and can handle it in the application thread. So by doing so, you can do the same what you can do with an swing worker, but you can do more because you can add as many executors, suppliers, consumers as you want. And in addition, the process chain has support for exceptions, and you can define a final task that will be called even if there was an exception while running the process chain. Okay, maybe a short demo. Let me see. Here it is. Okay, what I did here, I have a list and I create a process chain, and this is a more special example because the progress chain, like the swing worker, supports publishing of data or tasks. So what I did here, first in the platform thread, I will disable the action button when it is pressed. Then I will clear the list in the platform thread too. And then I will call a server task. It's this one. So I don't have a server, so I have inside a sleep that it looks like we have a slow connection and it will take some time. And simply publishing some values like value 1, 2, 3 till value 10. And this will be added automatically to the list in the JavaFX application thread. And once this is done, on an error, I will set the text of the button to error, and at the end, I will enable the action button. So when I start this, I simply can call the action, and as you can see, everything's working fine. The application thread isn't blocked because the complete server action is in the server action here because I have a sleep, will run in the background. Okay. Yes, okay, that's just an overview about the things that I have said. We have exception handling in it, and it's very cool, you can configure the thread pools in JavaFX. The service and task API is using a thread pool too, but you can configure it. It's hard-coded in JavaFX, and when using DataFX, you can configure the thread pool. So say how much threads should the pool have, or what's the minimum and maximum of the threads, and all the stuff. Okay, now I want to start talking about the Flow API. When creating a JavaFX application, normally you will have a lot of views like forms or tables or quad views. And normally, as Johan did in his demo, you will use fxml to create the layout of the view. And yeah, this is working fine. Here's a very simple example. It's some fxml code on the button. And by default, you will link from the fxml file to a Java controller. It's this my controller in the example. And this controller will be linked to the fxml file, and then you have a view, a layout that is defined by fxml, and a controller class in Java that will handle all the actions. In DataFX, we have some kind of inversion of control, as you will see, because we don't define the controller in the fxml file. Because we think you shouldn't define a class name with all the package in an fxml file isn't a Java file, it's just a text file. And what we did, here's an example about a ViewController in DataFX. We have an annotation, it's called fxml controller, and there you define the fxml file. So by doing so, you can you changed the control. So the fxml file didn't know the controller, but the controller knows the fxml file. In addition, by doing so, we support some other default Java annotations, like the post-construct annotation that isn't supported by fxml by default. Okay, by doing so, you can simply create one view. You have this controller class and you have this view class. It's working fine. But normally you don't have only one view. You will have a flow of views or a wizard or something like a quad dialog with a MasterDetailView or something like that. And there isn't any good solution in JavaFX to link between all these views. And that is what the Flow API in DataFX does. So let's think about this application. You have some views and you have actions that will link to another view, like open or details. On the bottom you have a settings view that can be accessed by any other view, for example. So that might be a map of an application workflow, for example. And with the Flow API in DataFX, you can do this very easy, and I will show an example by creating a MasterDetailView. So in a MasterDetailView, we will have two views. We will have the master view and we will have the detail view. What we want to do is use fxml to create the views, and we want to switch from one view to the other one. And what's very important, we want to hold the data. So when we switch from one view to the other one, we don't want to get all the data again from the server or something like that. So we want to transfer the data from one view to the second one. And we want to decouple all the stuff. So we don't want to have hard dependencies between all the views, because maybe we want to reuse the views anywhere else. So this is how this might look. We have this master view, we have this detail view, and we have some actions like we go to details, go back, or delete anything in the master view. As said, we will have an fxml file for each view and a controller that is written in Java, as I already showed. Okay, and now, by doing so, we can easily define a flow with DataFX. Here is some source code how this might look. So we create a flow, and we define the start view by saying new flow. This is the start view where the flow will start. And then we can define links from one view to another view. So we want to create a link from the master view to the detail view that is called details. And we want to create a link from the edit view to the master view that is called back. So that's the ID of the link. And again, we have this delete action on the top. So this isn't a link, but by using the Flow API, you can define actions. Here's an example. We say, okay, for the master view controller, we want to define the delete action. That's defined in the remove action class. Another option is to say, okay, we want to define the delete action and define a lambda that will be called once the delete action will be called. Okay, by doing so, we can create links, we can create actions for a flow or for a view of a flow, but the big question is, how can I call the actions? How can I get from one view to another one, or how can I call the delete action, for example? And here is how it is how it's working. We see the controller class of the detail view. And in fxml, we have defined a button called back button. And DataFX offers an annotation. It's called action trigger. And by annotating the button with the action trigger annotation, it will be automatically bound to the action that is defined for the flow for the back action ID, or that is defined for this view. So with DataFX, you can define actions, global actions for a flow, or an action for only one view. So you have these two options. And again, on the button, I use the post construct and pre-destroy annotation. These are the normal Java annotations, but DataFX will support them. Yes. Another option is if you don't want to define all your actions when creating the flow, you can simply create new actions in the controller classes. So here's an example. We have this action method annotation, and by using this, you can bind a button directly to a method in the controller. You don't need to do this. You can do this in FXML, but I think FXML normally designer, for example, will create the layouts and all the stuff in FXML, and the people shouldn't know which method should be called when I click the back button. I think this is better to do this directly in the controller in Java code. And with DataFX, you can do it by just adding these two annotations, and the delete method will be called whenever the back button is pressed. Okay, and let's talk about data. So as I said, we want to transform data from one view to another one, and therefore we introduced contexts. Context can be injected like a button or something that is defined in FXML by using an annotation. It's called the FXML view flow context, and this will inject the context for the complete flow. And in this context, you can register objects and reuse them or get them back in another view of the flow. I will show an example. Some other features, we provide back actions. So if you want to go one step back in the flow or to the previous view, you don't need to code it because we have a back action annotation. And by adding this on a button or on any other control, it will go back to the previous view once the button is pressed, or the control will. I think on a button and on a menu, it's whenever the action listener will be fired, and on each other control, it's whenever the mouse is clicked on it, for example. We use exception handlers in the flow too. So by default, each flow has one global exception handler, and whenever there's an error in the flow, for example, in a method that is called on a button click, whenever there's a runtime exception, or if you link to any controller or view that doesn't exist, the exception will land in the exception handler, and you can define whatever you want to do with this exception globally by whenever you define the flow. Oh, and flows are reusable, so you only need to define them once, and you can start them as often as you want. If you want, you can start them in parallel. Because whenever you start a new flow, a flow container is created. It's maybe something like this Java EE containers. And this will handle the flow and handle all the injection and all the stuff. Okay, I will show a demo. First one is a very simple one. I have two controllers. This is the first controller. It only has a button in it, and it defines a link action to view 2 controller. So whenever I click this button, the flow should move or go to view 2. And I have this view 2 controller. It's mainly the same. There's a button with a link to view 1. And the definition of the flow is very easy. I only say new flow and view 1 controller. This is the start view, and I want to start it in my stage. So that is not much code. And when I start it, I can click the button and go from view 1 to view 2 to view 1 and so on. So just a simple example. And what I did here, on the slides, I created the links between all the views and controllers when defining the flow. And in this example, I directly used annotations. That's another option to do it in the controller. So here I can say from this controller I will go to view 2. The other option is that I create everything when defining the flow. Here I can say, okay, I want to link from the start controller to the wizard1 controller, and the action ID is next, from the wizard1 controller to the wizard2 controller, and the action ID is next, and so on. And when looking in a controller, when looking in a controller, you will see that we have this action trigger next. It's a next button. So whenever I click next, this will be called. So what I did here is a simple wizard. So I can go next, next, next. I can go back. It's just this back action annotation. I can call finish, and you will go to the last step of the wizard. And sometimes you have a help, and yeah, there's only a system out. So how it is defined? I just say, okay, I have a new flow, and the start controller is the first controller, and then I have some links like from the start controller to the wizard1, and from 2 to 3, and from 3 to done. And then I have a global back action called back. So whenever the back action ID will be called, the flow should go one view back. Then I have a global link action to the last view. This is bound to the finish button. So whenever I click the finish button on any view, I will go to the last view. And here is the action. It's whenever I call the help button, it will print out something on the console. And this is a global action too, so I only need to define it one time and can reuse it in any view of the flow. Okay. And in combination with I will show this later. Okay, and a big benefit by doing so is if you use the flow API, you don't have any dependencies between the views. You only have this action IDs that defines the links between the views, and a view don't need to know the class of the next view. So by doing so, you can split your views in different modules, for example, and each module didn't know each other, and at runtime, they're all in the same class path, and then the flow is working. So if you have something like a help module or a settings module, you can call it from any view. Okay, the last one that I want to show is the injection API that is new, and it's integrated in the flow. And by doing so, you can inject data in your flow. It's based on on 2 JSRs. It's not completely implemented. There are some problems. I will talk about it. And it's deployed as a plugin on the Flow API. But it uses a default annotation, so like add inject. And it supports some scopes. So who knows CDI will know scopes. And for DataFX, we have 4 different scopes. The application scope and the dependent scope are the same as in Java EE. And we have 2 new scopes. It's the view scope that only lives in one view, and a flow scope that only lives in one flow. And by doing so, you can, I will show a short demo. So I hope it's working because I need Wi-Fi. This is a demo that uses the Flow API, the injection API, and data sources, and it's a music player, and I can search for any artist, and it will use the data sources API to search on iTunes. So it uses the iTunes web services and searches for the artists by using the data source API, and everything is created in a flow. So first I started with this view. Now I have an overview about all the CDs. I can open one, for example, go back. This is all done by the flow. And what's interesting, we always have the same data model, and only one time we created the data model, so I can even play a track if I want, so working. And this is done by using injection. So when having, for example, the album overview controller, I have an iTunes data model, and this is injected. And the iTunes data model has a flow scoped annotation. So this data model will live the whole flow. So whenever I inject this in one of my controllers, like in the detail controller where it's injected here, or in the overview controller where it's injected here, it will be the same instance because it is flow scoped. So it lives about one complete flow. If I would add view scoped annotation to the data model, it would only live in one view. And whenever I go to another view, it will be destroyed and a new instance will be created. So I think you know this from CDI. It's mainly the same. Okay. As I said, there are some problems with it. It's currently not based on a default implementation like Rel or Open Web Beans, because both of them are very Java EE specific. You have a lot of HTTP stuff in it and a lot of stuff that you don't need when doing JavaFX. Because of that, we started to create our own simple implementation, and so annotations like qualifier, for example, are not supported at the moment. But we created a plugin API so you can at the moment define your own scopes. We have this for scopes, but everybody can define its own scope. Yesterday I saw that someone created a scope for DataFX and used this plugin. That was very cool. Okay, so that was an injection API, and I think we're done. So
you can do the last slide. Yep.
So if you are interested, go to datafx.io and download DataFX. The sources are open source at Bitbucket. And yeah, we have a Google crew if you have any questions, or you can ask them now. Okay?
What's the license?
What's the license?
BSD. The BSD license.
Yes?
I talked to you about this before with RMI. And you provided me with like an example EJB RMI solution. Is that going to be something that's going to become like part of it?
The EGB stuff. Yeah, it's also, we want to release DataFX 8 this week, and everything that we've shown will be stable in DataFX 8. And we have, I can show it, some more stuff. Currently we call this DataFX Gaps. There are 3 more modules that aren't stable, and we've created a DataFX Incubator because they are not stable and not final for DataFX 8. They will be released as snapshots, and maybe in DataFX 8.1 or something like that, one of them will be part of DataFX. So it's the first one is a validation API. It's based on the Java Bean validation, so on the JSR that is used in Java EE2. And it's developed as a Flow API plugin, and by using it you can simply validate forms, for example, in JavaFX. And it's very cool because it supports the property API of JavaFX. So normally you can only add the validation annotations, add strings or primitives objects, and with the DataFX validation you can use the annotations for any property. And here's an example how it will look. But it's on the slides, and we will publish the slides. And another one, that's what you're talking about, is the EGB support. And with the EGB support, you can inject a remote EGB in your controller. So if you have, for example, a Wi-Fi and you have EGBs deployed on it, and there are not only local EGBs but remote EGBs too, you can inject them in your JavaFX application and directly call methods on them, for example. And at the moment we have a WildFire implementation. So we have this basic API and we have a WildFire implementation that is experimental. And that's it. We don't have any other implementation. And because of that, this isn't part of DataFX 8. And the last one is the feature toggle API. With this API, you can use feature toggles in a very simple way in JavaFX. So here's an example. We have two annotations, hide by feature and disable by feature. And by doing so, you can simply switch at runtime if a button should be hidden or disabled. So maybe you know the toggles API or you know feature toggles, and you can do it simply by using annotation. So these are the 3 projects that are currently in the incubator.
Any time frame on those?
No. So it's we do this for fun, and when I have time I will work on it, but and I'm not an EGB expert and not an application server expert. So the whitefire implementation was easy, but I don't know what's with all the other stuff. So I can I think the feature toggles will be the first that we will release, because this is mainly finished. And EGB and validation, I don't know.
We're an open source project though, so. Yeah. So we're an open source project, so join in and help out and file bugs and test it.
Yes.
And make builds.
Okay, other questions? Yes?
How's this tying with SceneBuilder?
It doesn't. It's more on the code side, right? Tying in with Scene Builder.
So if I'm using SceneBuilder,
You'd be calling this code from your controller. You wouldn't be using it.
so I can still define it in SceneBuilder, I just wouldn't hook anything up.
You define the views in Scene Builder.
Right. So Scene Builder is just
But I wouldn't do any hooking up of it because I've got the inversion control.
In Scene Builder, I can show you how I work, maybe. So this is a Canoe project I'm currently working on, and I use the Flow API tool. This is very simple. This is just a MasterDetailView, and what I did is I've created 2 controllers, one for the detail and one for the MasterView. And for each one I have an FXML file. So, and if you see, this is I have no idea how to do this in code. And yeah, I just use a scene builder. So here it is. And what I normally do, I only set the FX ID, so the name, and then inject it by adding add FXML in my controller, and everything else. So all the logic, so all the listeners and all the stuff I never do in FXML. I do this in the controller by using the Flow API. Yes.
So you will have tied it to a controller?
Yes.
Right?
Excuse me?
In the scene builder, you will tie it back to your controller even though you're not really going to use it?
I use the scene builder to lay out my controls.
Yeah, but you'll still have connected it to that controller, right?
Mm-hmm.
Yeah, so
Yes.
the controller, you see.
Okay. Yeah. Oh, yeah.
The value of the FXML controller refers to the scene builder.
Yes, yes.
And not the other way around.
Runtime, you're not really using that because you flipped it around.
Yeah.
Okay.
Okay. Thank you.